All right, C. Lindelof videos, change of variable for definite integration. And I did this exact same video yesterday, but I declared that my purpose of that was just to set up U substitution uh, with the intention of resubstituting in my U value later. So I didn't change anything, and you guys went crazy, and I got all these comments. So let me address that. Let me address that, please. So this is what I'm saying to you is this. This is what you guys were talking about, and you're right. I just wasn't going there yesterday. If you see the definite integral a to b of f of g of x times g prime at x, you can substitute that. You can integrate that using u substitution by saying I'm going to take the definite integral from g of a to g of b, g of a, g of b, of f of u du, letting u equal g of x. So that sounds like crap, kind of mushy. What am I talking about? Let's try that. I'll show you the whole thing. What I'm suggesting to you is this. Here's our problem. Our author has already assigned to us that u will equal this. So what I'm going to do here is I'm just going to take du dx. I'm going to take the derivative of this thing. And the derivative of that thing happens to be 8x. Well, that's really good news because I'm kind of probing around trying to figure out how to make this work. And I'm like, oh, look, there's this 8x. Why is there an 8x here also? Wouldn't it be great if they canceled one another? So before I go much further, I'm going to show you what I would do so far. I can't change this interval yet. I have 8x. Remember, though, that we said u is this thing, is 4x plus 1. So that is u, and it's squared. So this square is this one, dx. This is a problem because we have our integral in terms of the variable u and in terms of the variable x. Not cool. So what I'm going to do is this. I'm going to take this derivative. I'm going to solve for dx for a replacement value. If I solve for dx, I get dx is equal to du over 8x. It's a little bit of algebra. It's not quite as clean as it looks, but that is what it turns out to be. So again, it says here that dx is that, so I can replace dx with du over 8x. So hopefully you can see what's happening here. This and this cancel, don't they? Which would give me just 1 over u squared. Well, 1 over u squared is u to the negative second power, so I would have the definite integral from negative 1 to 0 of u to the negative second power du. This is where I stopped the video yesterday, and this is where I kind of got in trouble with some people. But what I said was, from here, if I was moving forward, I would resubstitute. I would take this piece right here, this 4x plus 1, and I would substitute it back into here after I integrated. And if I had done that, then my math would have been correct. So I left it a little bit vague. I apologize, but let me clean it up for you. Because what it says clearly up here is this, that we can integrate out of form of u if we use this substitution. So instead of getting negative 1 to 0, I get g of negative 1 to g of 0. And g of 0 is 4x squared plus 1. 0 squared is 1. I'm sorry, 0 squared is 0 plus 1 is 1, isn't it? To 1. Right? And here, what's g of negative 1? So g of negative 1 is 4 times negative 1 squared plus 1 is equal to 5. So from here, we could integrate, and we could take this value. So this is that correct form. Again, assuming that I'm going to integrate in terms of u, and I do not have any intention of resubstituting in that g of x value. So if I'm going to leave it in terms of u, I can do this. So I hope that provided clarity to your questions. I'm sure you're going to let me know if it didn't. Thanks for everything. If you have any questions or comments, let me know. Thanks.